Welcome. My name is Zishan Anwar, and in this video tutorial I'll show you how can you subnet class B IP address. For this I have chosen two tasks. In the first task you will be given a network that is 172.16.0.0/16 and you have to split this network into 6 subnetworks. And the second task is that is a little bit difficult, is you will be given a network that is 172.16.0.0/16 and you have to split this network into 500 networks. So now let's begin. Task number 1. You are given a network class B network 172.16.0.0/16, that is the default subnet mask of the class B, and you have to split this network into 6 subnetworks. What will you do first? You have to write down the binary form of the subnet mask. That is 16 bits are on and the next 16 bits are off, that is the host bits. The bit that is off is host bit, the bit that is on is network bit. The equivalent form of this subnet mask in the decimal value is 255.255.0.0. Now you have to change this network into 6 subnetwork. For this, for extending of your networks, you need network bits. For 6 network, how many network bit you will need to borrow? Here is a possible chart of that. List of network bits and subnetworks. If you need 2 subnetworks, you need 1 network bits. If you want to split any network into 3 to 4, then you need number of bits 2, and 5 to 8 you need number of bits 3. So here in this case, in our case, we have to split the class B IP address into 6 network, so we need only 3 network bit. So at the host bit portion I own 3 bits. Now the subnet mask is changed. The decimal value of this subnet mask is 255.255.224.0. Here is the value of this bit is 128. This bit has a 64 and this bit has a 32. So when we add 128, 64 and 32, the addition of these 3 bits would be 224, and this is the 0. Now in the new subnet mask we have 3 network bits. So the 3 network bits means total network 2 exponent 3 is equal to 8 subnets. We need 6 networks and we are getting 8 subnets. It means our requirement is fulfilled. Now the number of host bits are 5 and 8, means total 13s. 2 exponent 13 is equal to 8192 IPs. We will get in each and every network we are getting 8 subnetworks, and each and every subnetwork we will get 8192 IPs, in which 2 IPs, the very first that is the network IP and the very last that is the broadcast IP, will be reserved. So 8190 IP can be used on your system, on your end devices. So here, since you have now 8 subnetworks, so you made to define the range from where to where, right? So you can focus here subnetted octet. In the third octet we subnetted and we on 3 bits. So focus here the host bit number. So here is 5 host bit. 5 host bit is equal to 2 exponent 5 is equal to 32. 32 is range on the third octet, and we will go through 0 to 31. List and range of the subnetwork we will made here. So here is the network that was the given 172.16.0.0, and the range would be the very first network, because we have made 8 networks. Our subnet mask says that we have the 8 networks because we have opened 3 bits. So now 172.16.0.0 to 172.16.31. Why is here 31? Because our range is 32. So 0 to 31, right? It is the 32 in the third octet, and the fourth octet it is 255, because at the broadcast IP every bit is on. So when every bit is on of the fourth octet, it would be 255. This is the first range, first subnetwork of your subnetting. The next network would be 172.16.32.0 to 172.16.63.255, because here the last IP was the 31.31.255. The next IP would be 32.0, and the range would be 63.255, because third octet has the range of 32. So we start from 32, it ends with the 63, and the next is 64.0, 64.0 to 95.255, and so on and so on and so on and so on. So you can see here the started is 0.0 and the ends here 255.255. So this was the solution of your first task. Now we will move to the next task. Task number 2. In the task number 2, we say we are given an IP address that is 172.16.0.0 / 16, and we have to split this network into 500 networks, right? So we will do the first, we will change the subnet mask into binary. So it is the binary version 255.255.0.0 equivalent in the decimal form. So here we need 9 bits. You can go through that chart I will give you, and you will find that you need 9 network bits to make the 500 networks. Possible network is 512. So if we made 512 networks, so 500 network requirement will be fulfilled. And here I open 9 bits of the networks. 9 bits network means total network 512, and we need 500. My requirement is fulfilled. And here is only 7 bit of host. It means to the power 7, 2 exponent 7 is equal to 128 IPs. And the range we have subnetted in the third octet and the fourth octet, and the last octet is the fourth octet, and we subnetted is here, right? So we focus here the host bit, and the host bit is 7. So the range in the fourth octet would be to the exponent 7 is equal to 128. So now define the range, list and range of the subnetwork. So the very first 172.16.0.0 to 172.16.0, no changing up to the third octet. At the fourth octet we focused the number of bit, the number of host bit is 7, and the range is 128. So we go here 0 to 127, total 128, the very first network, and we have to make it 512 network. The second network goes from 127, and the next is 128. 172.16.0.128 to 172.16.0.120 because 128 and it has a range of 128, so we start from the 128, so it ends with the 255. The next range is 0.255, and later on 1.0 to 1.127, and 1.128 to 1.255, and so on and so on, and at the last you will reach 254.128 to 254.255, and the 255.0 and 255.127 and 255.128 to 255.255. So you will get 512 networks in this subnetting. So I hope you have understood the concept of subnetting of the class B IP address. I have given two tasks, and I hope you will get this. If this video is useful for you, please make a comment and don't forget to subscribe my channel. Thank you very much.